Hello everyone, my name is Desmond, and today I will be showing you how to find the percent mass of sodium bicarbonate within Alka-Seltzer and the limiting reactant and mass percent of NaHCO3 in Alka-Seltzer lab. So first of all, we want to find our before reaction mass of our entire contents of each trial. We can see I have 1 through 8 listed right here, and I just kind of plotted this chart out for like an actual visual so you can all see. So first of all, we're going to look at our data for each trial, and we see in my number 1 trial I have 142.24 grams with the beaker and this water. So that's for the first trial. So you're not going to have any vinegar for that one. So once you add the Alka-Seltzer with that, you get a before reaction of 145.47. So let's put that there on the first one. So 145.47 grams. Alright, and let's look at the after reaction. After reaction, 144.84 grams. 4.84 grams. Okay, so let's kind of get this demonstration done with converting to the mass of CO2 within each trial. So you see there's a difference in mass from before and after. So you know something was up. So we lost mass. So you make that calculation, you subtract 145.47, subtract 144.84, and that gives you the mass of CO2. In my case, for our lab, this was 0.63 grams of CO2. So let's put that in the mass spot, 0.63 grams. So there, you're nearly halfway done. So for finding the mass of NaHCO3, that's the next step. So we're going to have to put that in the formula of stoichiometry. So let's take a look here. We have 0.63 grams, so let's do some conversions. First, we're going to divide by the molar mass of CO2 to get our molar ratio later, comparing to the sodium bicarbonate over the CO2. And we see that it's a 1-to-1 ratio. And we know this because in the lab packet it shows us that in our first reaction we have 2 moles of NaHCO3 will later produce 2 moles of H2CO3 carbonic acid. So we know the molar ratios are the same. And as the carbonic acid breaks down into H2O and CO2, we know that it has the same amount of moles over here. So CO2 can then be converted. Alright, now looking back at the trial here, we divide by 44 grams, which is roughly CO2's molar mass, like I said, and then find the molar ratio, which will eventually get you the molar mass of, well, the moles, of NaHCO3, which turned out to be 0.014. And then you just find the amount of grams from there by multiplying by NaHCO3's molar mass, which is 84.0056 grams. So once you do that, you can find the mass of NaHCO3, and in our case, for the first trial, it was 1.18. So I can put that down there, 1.818 grams. So you're going to get somewhere roughly in that vicinity, the 1 range, and you'll see a tremendous difference as you go down the trials here. That's our first demonstration. So once you find the grams, how do you find the percent? That's the question. That is the real question. I'll tell you what. So once you find the grams, you want to divide by the entire mass of the Alka-Seltzer. So in our example for our first trial, the Alka-Seltzer by itself was 3.23 grams. Okay, that's easy enough. So like I said, once you find the mass of the NaHCO3, just divide by 3.23 in our case to find the percent of sodium bicarbonate within the Alka-Seltzer. And in our case, it was roughly 36%. So that's easy enough, you know. And you just do the same thing throughout each trial. You do the same thing, you find the before reaction mass compared to the after reaction, subtract the two, that'll get you your CO2 mass, and then from there convert to moles of NaHCO3 and then multiply by NaHCO3's molar mass to give you the amount of grams. And then from there, divide by the entire Alka-Seltzer mass, which in this case was 3.23, to get you your percent NaHCO3. Thank you, and I hope you enjoyed.